Good morning. All right, so something that we've done in the past, but now a little more formalized. I got some rules of exponents. We're going to be working with today, tomorrow, the rest of this week, and into next week before our unit test. So here we go. Here are the 7 rules. Just let B stand for any number, but we should know by now, after the amount of times we've gone through this, any number to the power of 0 is equal to 1. Okay? Remember, you guys should write this down in your notes. You can open notes quizzes. B to the power of negative n is going to be, you just remember we put this in the denominator to make it positive, so this is 1 over b to the power of n. Or another situation, what if our denominator has a negative exponent? Well, to make it positive, bring it to the numerator. So these are equivalent, just like these are equivalent, and I'm going to always stress that we're using positive exponents in the stuff we do. When I have b to the power of m times b to the power of n, that means when both bases are the same, but the exponents are different, you're allowed to add the exponents, okay? When you are doing a division problem, instead of adding the exponents, we're going to subtract the exponents, and that's all you get there. Over here, remember, I've been saying this in class, when I got a power to a power, that means you can only, this is the only time you're allowed to multiply the powers together to get that actual exponent. When I have this, I distribute the n, the exponent, to any of the, to all of the terms on the inside. So this goes here, this goes here. This is a to the power of n, b to the power of n. Then I got this one here. When I have a division, I have to do the same thing. I now distribute it to the numerator and to the denominator, so you get that right there. Back in a couple of seconds with some examples. All right, here are a couple examples. So first things first. If I got the same base but different exponents, I'm allowed to add the exponents. So this is equal to 3 to the 9th power. When I got a power to a power, I'm allowed to multiply the exponents. So this is equivalent to 4 to the power of 6. When I got a division problem, I remember I have to distribute this 2 to here and to here. But now the first thing that I would do if I were you, I chose these numbers on purpose because I want you guys to always try to simplify your answers before doing any work. So what I would do first to make your life easy, I would reduce 6 over 4 to 3 over 2. Now do this work. Just make your life a little easier. All right, always simplify. So this answer is going to be 3 to the power of 2 over 2 to the power of 2, or you can simplify this if you wanted to, 9 over 4. Okay, you're allowed to do that if you need to. Over here, I was purposeful on choosing these ones, all right? I erase these numbers just so we know that we're doing some stuff. I'm using this for the sake of time and space. I subtract my exponents. So the way that I'm going to do this, this is equivalent to 5 to the power of negative 3 because you take numerator exponent minus denominator exponent. But the way that I want you guys to always try to do this is try to always just ask yourself, which area do I have more exponents in, the numerator or the denominator? And in this case, I got 3 more in the denominator. So your answer is going to be 1 over 5 to the power of 3, or 1 over 125. Now this one over here, again, I did this one like this one because I want you guys to always reduce your fraction first. So this says the same as 1/2 to the power of negative 3. Do that first, habits in mind. And now distribute this. So now this is 1 to the negative 1 to this, and this is 2 to the negative 3rd, like such. Now, here's how we can do this. We can do this a couple different ways. I want to make both of my numerator and denominator positive. Because they're both negative, I can just flip. This is now 2 to the power of 3 over 1 to the power of 3, which is equal to simply 2 to the power of 3, or 8. All right? Because you're allowed to flip these completely when they're both negative. Another way to check this is you would have taken negative 3 minus negative 3. You set the difference of both, and you're left with this. So you're left with 2 to the power of 0. Sorry. Debbie downstairs. Ignore this. Just do what I said right there. That'd be good. I'll see you guys in class.